Good afternoon, everyone. Around 26 students have joined. Good afternoon, Satvik. Good afternoon, Puneet. Good afternoon, Navya. Good afternoon, Yashash. So all of you, yeah. So all of you went through the PDF that I have sent. Tell me, everyone. Good afternoon, Janvi. Just tell me, guys, have you gone through the PDF that I have sent on last class? Sunday, I couldn't take the class, right? Good afternoon, Aksa. Just tell me, guys. Good afternoon, Vikas. Am I audible? I'm clearly audible, right? Tell me, everyone. Okay, very good. So in last class, we studied about basics of permutation, right? Right, everyone? In last class, we studied about basics of permutation. Wait. What happened? Okay, yeah. Just wait, guys. Yeah. So if you remember, we have studied the basic concepts of permutation, right, everyone? So I will just revise what we have studied till now. We studied what is factorial. Factorial, right? Factorial is basically the continuous multiplication of natural number, right? The continuous multiplication of natural number up to n is your n factorial. Okay. Okay, Shakib, I'll just check into that. What is 0 factorial? Tell me, what is 0 factorial? 1. Very good. Very good. Then we studied fundamental principle of counting, right? Which, yeah. Okay. Fundamental principle of counting. So what does fundamental principle of counting? Fundamental principle of counting said that if we have two events, E1, which can occur in m ways, and even event E2, which can occur in n ways, right? Then the number of ways in which E1 and E2 can occur, right? E1 and E2 can occur is m into n, okay? Right? And the number of ways in which E1 or E2 can occur is m plus n, right? My voice is low. Guys, tell me, is my voice low? Vaishnavi? Okay, wait, I'll just wait. Okay, now tell me, now is fine? Okay. Okay, so yes, so this is fundamental principle of counting, right? Then we studied permutation. What was permutation? So permutation, okay, so permutation was number of ways of selection and arrangement. Selection and arrangement. Okay, and arrangement of R objects out of N objects, of R object out of N object. Right? So I can say that permutation is basically selection into arrangement of R objects. Right? That is your permutation. Got it? Yes? Yes, everyone? Okay. Now, when we talk about permutation, the formula of permutation was NPR. NPR. NPR means number of ways of selecting and arranging R objects out of N objects. So this is equal to what? Tell me. It is number of selecting R object, right, into number of arranging R objects. So tell me, right, in how many ways you can arrange R object? Tell me, in how many ways you can arrange R objects? We have already done that, guys. Tell me, in how many ways you can arrange three objects? Yes, Yashila, very good. In how many ways you, Puneet, R, I'm talking about R objects, right? So three objects can be arranged in 3 factorial ways, right? 6, which is 3 factorial ways. So R objects can be arranged in R factorial ways, right? Yes, Puneet. So it is R factorial, R factorial. So can I say that, right? Number of ways of selecting R object, selecting R objects is equal to NPR divided by R factorial. Yes or no? Tell me. Yes or no, guys? Okay. Right? Now think about it. Put the formula of NPR. Put the formula of NPR. So it is equal to N factorial divided by N minus R factorial into R factorial. Yes? Yes or no? Because yes, Aksa, Aditya, Ahad, Avya, everyone is getting. Zilan, Shakib,
Yes, sir.
Nandini, Navya, Srishti, everyone is getting easy. So what is this? What is this? This is number of ways of selecting only, right? It is not arranging, it is selection only, right? So this is selection, and number of ways of selecting our object is called as combination. It is called as combination. Okay, and it is represented by NCR. Okay, it is represented by NCR. Okay, Bhavesh, got it? Right? Now tell me, so can I say NCR is equal to NPR divided by R factorial? Yes, C is short form for combination, right? Same as P. Okay. Now tell me, can I do that? Yes or no, guys? Can I do that? Okay. Now tell me, what do you think? Which will be bigger, right? Number of ways of selection only or number of ways of selection and arrangement? which means NCR will be bigger or NPR will be bigger? Tell me. Yes, very good. Permutation will be bigger. Permutation, na Navya, right? Because see, right? NCR, which is combination, is NPR by R factorial divided by N factorial. Yes. So I can say that NPR should always be greater than equal to NCR. Yes or no? Yes or no, guys? Got it? Got it? Okay, very good. And there's one more condition. What is the second condition? R should also be less than equal to N. Can R be more than N? Can you arrange 10 objects out of 5 objects? Think about it. Can you arrange, okay, 10 out? No, na? So R should always be less than equal to N, right? Yes, yes. NCR is, right, only selection. Means if you're only selecting 3 objects out of 10 objects, then it is, now where you it's not cutting, right? You have to select already existing elements. Okay, okay. Now think about it. Let's see some properties of combination. Okay, some properties of combination. Now tell me, 10 10C8 10C8 is equal to what? 10 factorial divided by 10 minus 8 factorial into 8 factorial. Agree? Which is basically 10 factorial divided by 2 factorial into 8 factorial. Yes or no? Tell me, guys, yes or no? Now, I can write this as 10 factorial divided by 2 factorial into 10 minus 2 factorial. Yes or no? Think about it. Right? And what is this? This is 10C2. Right, guys? Right? So what I proved, what I just proved, I said that 10C8 is equal to 10C2. Is there any relation? Tell me, is there any relation between them? So if you see, it is NCR, right? And this is NCN minus R. Okay, got it? So this is your first property. This is your first property, right? First property says that NCR is equal to NCN minus R, which means suppose I'm talking about 10C0. 10C0 is equal to 10C10. Okay, or 10C3 is equal to 10C7, or 10C8 is equal to 10C2 that I've just proved, right? Got it? Got it, guys? First property. Everyone, Navya, Shakib, got it now? Shrishti, Darshan, Srushti, Srisha, Tanish, Sukirti. It is in bracket only, वो understood है, ठीक है विकास? That's understood. यशश, अव्य, ठीक है? See, n minus r वो understood है, ठीक है? It is understood that ये एक ही term है पूरा, ठीक है? Now, this is your first property. This is your first property. Now, second property. Now, this is something which I want you to prove, okay? try to find 10C3 plus 10C2 is equal to 11C3. Prove करना है इसको, prove. Right? Guys, I'll be also doing, you guys should also do step by step, right? Okay, please do with me, step by step. So what I should do, I should start with LHS, right? I'll start with LHS. Okay, so 10C3 can be written as 10 factorial divided by 10 minus 3 factorial into 3 factorial. Guys, got it? Wait. 3 factorial, okay? Plus, this is 10 factorial divided by 10 minus 2 factorial into 2 factorial, right? Step 1, anyone have any issues? I just wrote the basic formula, okay? Right? Now tell me this, 8 factorial is bigger or 7 factorial? Tell me, out of these two, which is bigger? 8 factorial or 7 factorial? Right? Very good. Now, n minus 3 factorial. I've already asked this. N minus 3 factorial is bigger or n minus 4 factorial? Which is bigger? This has nothing to do with this problem. I'm just asking you. N minus 3 factorial is bigger or n minus 4 factorial is bigger? Yes, Yashash. Very good. Very good, Vaishnavi. N minus 3 is bigger, right? This is bigger. Yes, very good. Very good. So all of you understood the concept of factorial. Now see this. Can I take 10 factorial common from the numerator? 10 factorial common. So I'll be left with 1 divided by, this is 7 factorial into 3 factorial plus 1 by 8 factorial into 2 factorial. I'll be using step-by-step calculation, okay? Now, what do you think? Can I write 8 factorial in terms of 7 factorial? 8 factorial can be written as 8 into 7 factorial. In the same way, 3 factorial can be written as 3 into 2 factorial. Always write, yes, always write bigger factorial in terms of smaller factorial. Okay, always do that. So this can be written as, okay, this can be written as 10 factorial divided by 1 by 7 factorial into 3 into 2 factorial plus 1 by 8 into 7 factorial into 2 factorial. Now, can we take out anything? Can we take anything common? Tell me guys, can we take anything common? Yes, very good, right? So 10 factorial, if we see 7 factorial into 2 factorial is common. Very good, Yashash. So we will take 7 factorial into 2 factorial common. So we are left with what? We are left with 1 by 3 plus 1 by 8. I hope everyone knew LCM. Everyone knew LCM. So this will give me what? 10 factorial divided by 7 factorial into 2 factorial into 11 by 3 into 8. Got it? Everyone is getting till this step? Everyone is getting till this step? Raise your hand. You don't have to multiply, Yashash. You don't have to multiply the denominator. Just write it as it is, okay? Okay. Now let's see this. If you see this, we already got the answer. 10 factorial into 11 divided by 7 factorial into 8 into 2 factorial into 3. Tell me what it is. What it is, guys? Isn't it 11 factorial divided by 8 factorial into 3 factorial? Yes or no? I'll scroll up, don't worry, Shakib. Now, this can be written as 11 factorial divided by 11 minus 3 factorial into 3 factorial. Now, it's just the representation, right? Okay, it's just the representation. So, it is proof that it is 11C3. Okay. Got it, Nitin? Everyone, take your time, write it down in your notebook. Okay. This is one property. So I have just taken one example. I will generalize this. Okay. This is one property. Okay. So what is the general property? General property is this: NCR plus NCR minus 1 is equal to N plus 1 CR. This is your general property. Okay. Yes, Vikas. Okay, Shirsha, I'll explain the last third step. So first, I'll start with first step, right? Okay, this step everyone got. This step everyone got. Step one, everyone got. Just raise your hand, okay? If anyone didn't get, please message. Very good. This is step 2. Everyone got step 2. Okay, very good. Step 3. Then this is step 4. Step 5. Anyone have any doubt till step 5? Okay, no doubt. Very good. Then we have, this is step 6. Shresha, you have doubt in step 6? Step 7, step 8, and this is the answer. Okay, so 6, 7, 8. Step 3, top. Okay, step 3. So see, step 3 was this. This was step 3. So if you see this, we had 7 factorial into 3 factorial. And here 8 factorial into 2 factorial. So I can say that 8 factorial is bigger than 7 factorial. Right? So I will convert 8 factorial in terms of 7 factorial. How? 8 factorial can be written as 8 into 7 factorial. So I've written 8 into 7 factorial over here. Okay. In the same way, 3 factorial is bigger than 2 factorial. So 3 factorial is written as 3 into 2 factorial. 3 into 2 factorial. Okay. Now we have 7 factorial into 2 factorial and 7 factorial into 2 factorial, which can be taken as common. Okay, Shirsha? Got it? Everyone got this? Okay, very good. See, 3 into 8 is obviously you can write as 4 factorial. Okay, right? But you don't have to write because you have to convert this into this form now, right? That's the thing. So, general formula, that's the second property, is this, right? NCR plus NCR plus 1 is equal to, sorry, N minus. Okay, tell me what is the formula here? Tell me, what would be the formula of this one? It will be N plus 1, CR plus 1. I just wrote something by mistake, right? Actual formula was NCR plus NCR minus 1 is equal to N plus 1 CR, right? Now tell me, this formula and this formula is actually same, yes or no? Right? They're actually same. Yes, guys? Because r minus r plus 1 r, or r into r minus 1, sorry, r plus r minus 1, it's almost same, right? So sometimes if this formula is given, it's also correct and this is also correct. Okay, just think about the concept, right? Because see this, now see this 10c3 plus 10c2 is equal to 11c3, right? This is correct for this formula also as well as this formula also, right everyone? Got it? Got these two formulas? Okay, so you guys might be thinking, okay, so these are the properties, where to use this, right? Where to use this combination? Okay, now think about it, I'll just give you one simple application, right? One simple application. Obviously, we'll discuss many other concepts. Now, just think about this. Suppose we have x plus y square. Tell me, what would be the answer? You might be thinking, so what you are doing, right? Yes, yes, Vikas, right? First, tell me, what is the answer of this one? X plus y whole square. Everyone know this, right? Very good. It is x squared plus 2xy plus y square. Okay, very good. What about x plus y whole cube? Tell me, what is x plus y whole cube? Anyone? Or x plus y whole power 4, or x plus y whole power 7? If I tell you that you can actually solve, you can, yes, okay. So x plus y whole cube, you said it is x cube plus 3x square y plus 3xy square plus y cube, right? Now if I tell you that you can find anything using what you just studied, right? Then yes, how to power 7th power. Now think about it. How can you use combination here, right? Someone might ask, now, okay, that is the difference between the concept that you think. If I tell you, you can find x plus y power 7, right, using the concept of combination. How? Think about it. Think very basic. Forget about everything that you have studied. Think very basic. What is x plus y to power 7? It is x plus y into 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 x plus y. So 3 into x plus y. Right, everyone? Right? Okay. Now just imagine, forget about maths for now. Just imagine, or forget about this. Suppose you have apple, mango, apple, mango, apple, mango, right? So how many baskets? 7 baskets. 7 baskets, and each basket have 1 apple and 1 mango. Okay, got it? 7 baskets, each having 1 apple and one mango. Okay, yes or no? Now tell me, what is the maximum number of, and the question here is, you can only select, right? Okay, now tell me, you have to take, right, one fruits from any basket. You have to take only one fruit from any basket, right? One fruit, sorry, for one fruit from all the baskets. You have to take one fruit from all the baskets. So at what time? At a time you should have how many fruits? Tell me. At a time you should have how many fruits? 7 fruits, na? You can take one fruit from every basket. That's the thing. 7 fruits, right? So always you have to pick 7 fruits. Okay. So my question is, in how many ways you can do that? See, how can I just transform this? My question is, in how many ways you can do that, right? No, 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 no. Let's think about this, right? Let's think first choice. First choice. Select only apple. That's the thing, right? Just think. Select only apples. How many apples do you have? Tell me, how many apples do you have? 7. And if you're selecting all the apples, right? The number of selection of apples would be how much? Selection only selection. Think about it, na? You have 7 apples. You have 7 apples, and you're selecting all 7 apples. 7C7, right? So it can be done only in one way. Nitin, it is combination. It is not permutation. Okay. If you have 7 apples and you are selecting all 7 apples, it can only be done in one way, na? Tell me yes or no. Got it? Right? Everyone is getting this? Now, if you're selecting all the apples, what about mangoes? How many mangoes you're selecting? If you're selecting all the apples, then how many mangoes you're selecting? 0, na? 0. Obviously 0, right? If you're selecting all the apples, so you're leaving out mangoes. Okay. So mangoes, it would be 7C, 0. Now there you have to pick one fruit from all the baskets. You have selected only apples, so you have left out mangoes, na? Okay, okay, got it, Navya? So this is what you have selected, what apple. So X is apple, X apple. How many apples? 7 apples, right? Into Y is mango, mango. How many mangoes? 0 mangoes, right? Okay, plus, plus. Now, now you have to select 6 apples, right? 6 apples and 1 mango. In how many ways you can do that? 6 apples. Tell me. No, just write in terms of combination only, na? Think about it, right? You have 7 apples. Out of 7 apples, you have to select 6 apples. Yes, Vaishnavi. Sorry. Yes, Nitin. Yes, yes, yes. Think about what I said. You have to select 6 apples out of 7 apples. So it should be 7C6, na? Yes or no? Yes or no, guys? Think about it. Srishti, right? Odd, odd. Or you could say that you are selecting 1 mango out of 7 mango, right? You can say any of the two, na? Think about it. Think about what I just wrote. Yes, yes, exactly, Shakib. You can choose only 1 fruit from each basket. Okay, you can only choose 1 fruit from each basket, so that you should have only 7 fruits. Puneet, okay, Puneet, just think about it. Now you have how many apples? Tell me, you have how many apples? 7 apples, right? Yes or no? Yes or no? Tell me. Now, either you can choose all 7 apples, or 6 apple, 1 mango, right? 5 apple, 2 mango, 4 apple, 3 mango, sorry, right? 3 apple, 4 mango, right? These are the combinations that you can have, yes or no? Vikas, right? X and Y are the values. I just explained, I just used apple and mangoes for better understanding, right? Obviously, it is not just apple mango, na, right? X and Y are some variables which will have some values. Okay. I used this apple and mango because it feels like a better example. Okay. Right now, next should be what? Tell me, next should be what? Plus what? Next should be what? After 6 apple, 1 mango, we should have what? 5 apple, 2 mango. Tell me, so what should be the term? Tell me, guys. 7c5, right? X to the power 5 and y power 2. Yes or no? If you see this, if you see the power of variables, it is always 7. It is always 7. Yes or no? Right? Or you could just write like this: 7c2 in terms of mangoes, y square x to the power 5. Now, if you observe, 7c5 and 7c2 are equal. So basically, this term and this term are equal. 7c6 and 7c1 are equal. So this term are equal. So actually, it is just the same thing. Right, everyone? Right? Right? So next term should be what? Tell me. Next term should be what? Next term should be what? Tell me. Yes, Shush. You can write in terms of, because are you selecting 6 apples or are you selecting 1 mango? Both are same, na? Because if you're selecting 1 mango and 6 apple, or 6 apple and 1 mango, they're same but reversed, right? Yes, very good, Vikas. Very good. So next term would be 7c4 x to the power 4 into y to the power 3. Now 4 mangoes, sorry, 4 apple, 3 mangoes, or 7c3 y to the power 3 into x to the power 4. Right? Very good. Very good, everyone. Plus, write down all the terms. Write down all the terms. See how many terms we will have. Puneet, we have only 7 apples, Puneet, right? We won't have 8 apples, so power should be 7 always. Eight terms you will have, guys. Check. You should have 8 terms, not 7, 8 terms. Okay. So I will just rub this one. I'll just rub this one so that I can have space. Okay. So after this, I will write 7c3 x to the power 3 y to the power 4 plus 7c2 x to the power 2 y to the power 5 plus 7c1 x to the power 1 y to the power 6 plus 7c0 x to the power 0 y to the power 7. See how many terms? See how many terms? 8 terms. Yes or no? Yes or no? Are you getting my concept? Are you getting this concept? Because 0 to 7, na, it is 0 to 7, right? 0 to 7 is 8 terms. Hai na? Now I'll give you one better way. Now, if you think about this, x plus y whole cube, if you think about this, right? Just think about this formula only. So n is 3c, right? 3c3 x to the power 3 y to the power 0 plus 3c2 x to the power 2 y to the power 1 plus 3c1 x to the power 1 y to the power 2 plus 3c0, x to power 0, y to power 3, right? This will be x plus y to power 3, 4 terms. Yes or no? Yes or no, guys? If you see this, 3c3, 3c3 is what? 1. You can calculate 3 factorial by 3 factorial into 0 factorial. It is 1, 1 x cube, because y power 0 is 1, plus 3c2 is 3x square y, plus 3c1 and 3c2 are same, right? So it is 3xy square, plus 3c0 and 3c3 are equal, so 1y cube. See, this was the formula, na? Yes or no? This was the formula. Yes or no? Tell me, guys, yes or no? Now, can you write any formula now? Can you write any formula? Now tell me this, right? Just think about it. Just think about it, right? Isn't it interesting, right? That we use the concept of, right? It is, again, it is, everything is very fundamental. Okay, if you think about it, whatever we did, it was very fundamental. Yes or no? Right? Yes, it is binomial theorem. Yeshila, it is binomial theorem. Now, if you see this, right? If you see this, right? I will just show you this. 1, 1, 1, 1, 1 plus 1, 2, 1, 1 plus 1, 1 plus 2, 3, 2 plus 1, 3, 1, 1 plus 3, 4, 3 plus 3, 6, 3 plus 1, 4, 1, 1, 1 plus 4, 5, 4 plus 6, 10, 6 plus 5, 10, 4 plus 1, 5, 1, 1, 1 plus 5, 6, 5 plus 10, 15, 10 plus 10, 20, 10 plus 5, 15, 5 plus 1, 6, 1, 1, right? Now think about this. You can go on. Think about this. X plus y to the power 0 is equal to what? X plus y to the power 0, what? 1, 1. X plus y to the power 1 is equal to what? X plus y to the power 1 is equal to what? X plus y, right? So 1, 1. Coefficient, just see the coefficients. Okay, just see the coefficients. 1, 1. X plus y whole square is equal to what? X squared plus 2xy plus y squared. See the coefficients only. X plus y whole cube is x cube 3x square y 3xy square y cube. See this, x plus y to power 4, x to power 4, 4x cube y 6x square y square 4x y cube and y to power 4. See, see, are you getting? Tell me, isn't it interesting? Tell me yes or no, right? And just think about it. Think from yourself, right? Think it. Is it very hard? Is it very hard to think or to remember or to intuitionally solve problems based on this? Right? This triangle, if you remove this x square and all those things, I'll just remove this, okay? I'll just remove this again. This is only one application, right? This triangle is called as Pascal's triangle. Okay, I will teach you something very interesting now. Okay, very interesting. This is 3. This is 1. This is called as Pascal's triangle. Okay, you can just go through. So it is now people might say put x is equal to 1 and y is equal to 1. Put x is equal to 1 and y is equal to 1. So it is 1 plus 1, right? Okay, right? It's not 1 plus 1. It's basically put x is equal to, uh, okay, it's fine. Leave it, right? Not 1, 1. It's basically, it is 11, 11th power 0, 11th power 1, 11th power 2, 11th power 3, 11th power 4, 11th power 5, 11th power 6, and so on, right? Or there are multiple properties, right? This Pascal's triangle. See, 1, 1, 1, 1, 1, 1, 1, 2, 3, 4, 5, 6, 7, 1, 3, 6, 10. So 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15, 15 plus 6. Next term should be what? 21, right? Okay. So this Pascal's triangle have lots and lots of properties. Even I don't know all the properties. Okay. Now, are you ready to blow your mind? Tell me, are you ready to blow your mind? If I ask you, something similar but different, right? Something similar but different. If I'm asking you x plus y plus z, x plus y plus z whole square. Now tell me, x plus y plus z whole square. Okay, Krishna. No, 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 you won't die. Think about it. It is very easy, very easy. I'll just take bit by bit, right? Step by step. See, learning is interesting, right? Because you don't have to worry about marks or scores. You just have to learn. If you enjoy it, you learn. Okay? Very good. Very good, everyone. Very good, Navya. So everyone remember this formula, I guess. Everyone remember this formula, I guess, right? Which is x squared plus, tell me, 2xy plus 2xz plus 2yz plus y square plus z square, right? Okay, very good, everyone. What about this? Let's just notch it up. Tell me now. Tell me this. Can you solve this using the concept that we just studied? Okay, I'll give you a hint. I'll give you a hint. Try to make a similar triangle. Try to make a similar triangle. Right? I'll give you a hint. One. But now here we have three terms. So one, one, one. Okay, what now? What now? One, one plus one, 2, 1 plus 1, 2, 1 doesn't seems right. There should be some error. This is some error, right? Right, some error. What we have to do? No, some error, right? So we have to do something. Think yourself. Okay, I muted myself. Can you hear me? This is obviously, it is not right. This is not correct. This is not we should do. This is not we should do. My voice is cracking. Wait, everyone, wait. Okay, guys, can you hear me? Tell me, can you hear me now? Yes. So I will give you a bit simpler problem, right? Tell me, what is this? 1 plus x square whole power 0. What it would be? What it would be? Very good, Abhay. Very good, everyone. Anything to power 0 is 1, na? 1. 1, right? Now, 1 plus x squared to power 1 is what? 1 plus x squared power 1 is equal to what? Same only, right? So it is 1 plus x, 1 into x plus 1 into x squared. Agree? Agree? Right? Next, 1 plus x squared the whole square. If you see this, right, then it is becoming difficult, right? You have to multiply, right? You have to multiply. Now, but if you use the same concept of Pascal's triangle, right? I will just rub this, I will just rub, okay. If you use the same concept of Pascal's triangle, then think about it. 1, add these two, 2, add all the 3, add these 2, right? 1. Think about it. This is 1, right? Then try increasing power. This is x, then power x squared, then x cubed, then x to power 4. Because the highest power should always be x to power 4, yes or no? Tell me, think about it, yes or no? Think about it, guys. Now, next term, what do you think? Next term, 1 plus x squared to the power 3. Again, think about it, what it would be. It is just like Pascal's triangle. Now, 1, 1, 1, 1. So in Pascal's triangle, we're just adding these two and these two. But here we have 3 terms. So these 2 plus all the 3, then these 2, right? Then last 1, 1. Okay, it is just the way to write, to make the simpler calculation. Okay. Think about it once again. Okay, 1 plus x square whole cube, right? 1, 1 plus 2, 3, 3 plus 2. Think about it. No, that's a mistake, because see, if you're going to this, right? If you're going to this, right? See, this is not just like binomial, okay? So when you go, yeah, when you talk about this term, so all the 3 should be added. All the 3 should be added, okay? All the 3 should be added for third term. So 1 plus 2 plus 3, 6. Okay, three terms, three terms, because you have to pick three terms, right? Then for this, right? All the 3 terms, 2 plus 3 plus 2, it is, tell me, 7. Then this, 2 plus 3 plus 2 plus 1, 6. Then 2 plus 1, 3. Then last one. Okay. Yes, Darshan, 1, 3, 6, 7, 6, 3, 1. Now, if it is too much, don't worry, right? Okay, it is just like one triangle, which is like Pascal's triangle. Here it will be what? 1, 1 plus 3, 4. Now this would be sum of these 3. 1 plus 3 plus 6, 10. Then tell me sum of these 3. 3 plus 6 plus 7. which is 16. Then sum of these three, 6 plus 6, 12 plus 7, 19. Sum of these three. Then sum of these three, which is again 16. Then sum of these three, which is again 10, 4, 1. So here, instead of 2, 2, we are adding 3, 3. Okay, in the middle terms. Are you getting everything? In Pascal's triangle, we are adding 2, 2 now. We are adding 2, 2 terms. Here, since it is trinomial, right? We are adding 3, 3 terms. Okay, this is one more fun triangle. If you don't remember, don't worry. Even your seniors, even their seniors don't know this. Okay, so don't worry about this, right? But I was just saying that how fun it is, right? Okay, if you think actually, if you think how fun it is, okay, how can you write in terms of combination or just use the common concepts? Okay, okay, everyone. Okay, so this was the concept of binomial and trinomial. Binomial means two terms. Binomial means two terms. So this was the concept of binomial, and this is the concept of trinomial. Okay. Now x plus y plus z problem will be way too difficult for you, Yashash, for now, right? So leave it for now because that is multinomial. Okay, that is not binomial or trinomial. That is multinomial, right? So that is way too difficult for you guys for now. So leave something for next year. Okay, right? I guess this is more than enough to digest. Yashash, next year, right? Next year, join foundation class. Okay. Next year, I'll teach you something interesting. Anyways, I haven't started physics yet, right? After we have completed force and all. Okay. So I will give you a bit, some basic examples of combination, right? Some basic examples. No, we will have till 5, Krishna. We will have till 5 today, okay? Okay, guys, and one more thing. From next week onwards, your schedule might change a bit. Okay, right? We will have to 5 only 1.5 hour only because it will be too much for you guys. Okay, because I'm just teaching, right? So it will be too much to keep in your mind. Don't worry, I'll keep 1.5 hour class on Sunday also. Don't worry. Okay. Okay. Now let's see some problems of combination, right? Suppose, let's see one problem, guys. Let's see one problem. Because I'll tell you afterwards, it will be informed, don't worry. So suppose one problem, we have a problem, we have uh, 8 women, 8 women and 10 men. Okay, 10 men. You have to form a committee of 5 people, right? Having 2 men and 3 women. In how many ways you can do that? In how many ways you can do that? Think, guys, right? Use the concept of combination that we have studied till now. Okay, think. This is very easy question. I don't want a number because I haven't calculated. Just say in terms of combination. Okay. Think about this. Okay, I'll just explain this for you. Okay. Now think about this. How many men do you have? 10 men, right? And how many women do you have? 8 women. Now think about this, right? Yes, Yashash, it's correct. Very good. Now out of 10 men, how many men you have to choose? 2, right? Out of 10 men, you have to choose 2 men. In how many ways you can do that? Tell me, in how many ways you can do that? What is the number of ways of choosing 2 men out of 10 men? Yes, very good. Everyone think about it. 10C2. Yes or no? Yes or no? 10C2 na? 10C2, right? Now we are 10C2 na? Right? Number of ways of selecting 2 men out of 10 men is 10C2. In the same way, out of 8 women, you have to choose 3 women. Tell me. So what it would be? 8C3. Got it? Right? Now, what you have to choose? What you have to choose? Yes, Sahana, very good. Right? Very good, Sahana. 8C3, Sahana, 8C3. Okay. You have 8 women. You have to choose, you have to make a committee of 5 people, 2 men and 3 women. And 3 women. So what it would be? Number of ways of choosing 2 men and multiply 3 women. This should be your answer. After solving this, whatever you get should be your answer. Got it, guys? Tell me. Got it? See, these things are very conceptual. One line is more than enough to write the answer, but that one line you have to think. Okay. Now, see, I will just take the same question, right? Okay, same question, but I'll change this. The question is, the committee of 5 people of 5 people having at least 3 women. At least 3 women, okay? Tell me now. Think about it. Think about it, guys. At least 3 women now. These are brain-racking questions, okay? No formulas, no calculation, just concept. Think and write one line. What has changed? First of all, ask yourself, what has changed in this question from previous question? Tell me, what has changed? In previous, I have given that 2 men and 3 women fixed. But here, are the team members fixed? Tell me. No, Sahana, it is at least 3, right? Again, men. Yes, Yashash, very good. Now, see, this we will have many cases here, right? We have different cases. Case 1, at least 3 means 3 women, 2 men. What's the meaning of at least? Means we can have more than 3 women also, right? Yes or no? And Vaishnavi, it is multiply, right? Okay. At least means you can have more than 3 women also. So case 1 is this. What is case 2? Case 2, we can have 4 women and 1 man. Case 3, all 5 women and 0 men. Think about this, yes or no? So you can have this case 1 or case 2 or case 3. Yes, everyone? Think about it, yes? See, try to understand. It has nothing to do with maths for now. You just have to think. If your teacher asked you to make a team and you say that okay, a team can have like minimum of 3 girls. So you have this option now. You can have 3 girls or 4 girls or 5 girls, right? All the 5 girls, right? Or right now, see the first case. First case, 3 and number of women is 8, and this is 10. So what is this? This is 10C2 into 8C3, right? What about this one? It is 10C1 into 8C4. What about this? It is 10C0 into 8C5, right? And this is plus or plus, right? So the actual answer will be what? 10C2, right? Sorry, 8C3 into 10C2 plus 8C4 into 10C1 plus 10C0 into 8C5. This should be your correct answer. Everyone got this? No calculation, right? No calculation, just concept. You don't have to calculate all those for now. Even though, even in exams, you will be asked to find like this. Mostly it will be in this form, okay? Got it, guys? Everyone should get this. Every single person should get this. Okay, very good. So now you understood what is the difference between combination and permutation. Everyone, did you get the idea, right? What is permutation? What is combination? So if you talk about ordered objects, right? Selecting and arranging ordered object. If you have to mention the order, then you should use permutation and combination. Tell me. If order will be important, use what? Permutation or combination? Permutation. Yes, very good. So if order is important, then you have to use permutation. But if order is not important, right? If order is not important, then combination. Very good. Got it, guys? Got the difference? Okay, very good, everyone. Okay, let's try to solve some problems. Can you see the problems? Okay, these are easy questions. Reading one was easy questions. Okay, so see the first question. See the first question, guys. Melissa is not here. Melissa is here. Ashnavi, Jaita. Jayati, are you getting everything? Tell me, Jayati, are you getting? Okay, very good, Jayati. Janvi, Darshan, Nandini, Satvik, you guys are getting? Okay, very good. Now see this, right? See the first question. Okay, this one. How many chords can be drawn through 21 points on circle? Tell me, one line. See, that's the thing, right? You have to think. Okay. Now, what is a chord? Tell me, what is a chord? Chord will join how many points? Chord will join how many points? 2 points. And how many points do you have? How many points do you have? 21. So in order to draw a chord, you have to choose how many points from how many points? You have to choose two chords out of 21 points. Yes or no? Think about it. Yes or no? Right? So what it should be? It should be 21 C2, right? No, I'm just, I was laughing at some of the answers. Okay, right? But there's a catch. There's a catch over here. Why? What is the catch? See, if you talk about a circle, right? Right? If you take this 2 point, okay, this 2 point. So this, yeah, okay. Try to find question number one, guys. Question number one. Question number one. No, no, now, yeah. Like I was just like most of you were saying something like anything. I was getting someone said infinite also. I don't know. That's why. And someone said zero also. So that's why. Like they were having fun, I guess. So that's why I started. So question number one, see, find the total number of 5-digit number with at least one repeating digits. Now, I guess these questions might be way too difficult for you, right? Let's tone down the problems. Okay. Leave that, guys. Leave that question. Okay, leave that question. We'll just solve this. So have you solved this problem? Tell me, have you solved question number 14? Have you solved these problems? I don't remember actually, that's why. No? Okay. Try solving question number 14, guys. Try solving question number 14. Try solving question number 14 for now. Okay, try solving question number 14. This is based on first thing that you should ask yourself, that it is based on permutation or combination. It is based on permutation or combination. Think about it. Tell me, permutation or combination? Yes, very good. Permutation, because it is arrangements. Whenever it is arrangements, it's permutation. Okay. Now, yes. Now, is it one special case? Is it any special case? Yes, it is the special case in which objects are objects always together. So if you remember the formula, okay, right? Okay, so it was n minus r plus 1 factorial into r factorial, yes or no? Tell me, yes or no, right? If out of n objects, r objects will be together, then this was the formula, right? Now tell me, in daughter, G, A, U, G, H, T. Yes, it is special case too. So these three are vowels, so you have three vowels, right? So, and total alphabets are 8. So it will be 8 minus 3 plus 1 factorial into 3 factorial, yes or no? Tell me guys, yes or no? 6 factorial into 3 factorial, na? Now yeah, it is 6 factorial into 3 factorial, right? Because these three will also be one object, yes or no? Right? Okay, right everyone? Now what about second one? What about second one? This is the last problem of today's class. What is the total number of arrangement? Tell me, what is the total number of arrangement? Total number of arrangement will be 8 factorial. 8 factorial. Agree? Total number of arrangement is 8 factorial. And this is the number of ways in which all vowels are together. All vowels together. Yes. So what do you think? What would be the answer that no all vowels will be together? It is total minus all vowels together, yes or no? Tell me. Right? If you subtract number of ways in which all vowels will be together from total, it will give you the second case, right everyone? Okay, okay, very good guys. So this is called as rule of rejection. This is called as rule of rejection. Okay. That's it for today. today's class. I hope all of you learned something and enjoyed the class, right? Okay. 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 Thank you, everyone. Bye, everyone. Yashash, Kahoot is of difficult level and it will take lots of time. Okay. Right. So I will use Kahoot as a test. Okay. Okay. Bye, guys. Bye, everyone. Bye, Navya. Bye, Satvik. Bye, Vikas. Bye, Darshan.